I'm not going to dwell too long on Tetrode valves. This is because they were quickly superseded by the Pentode, which we'll discuss in the next videos. One type of Tetrode which is still used is called the beam Tetrode, and it has characteristics which are very similar to the Pentode and can be used in the same way. The Tetrode was an attempt to overcome the problem of capacitance or electrostatic coupling between the electrodes of a triode, particularly the grid and the anode. We discussed this issue in the previous videos about triodes. The basic idea is to add a new second grid into the structure, and this shields the control grid from the influence of the anode. This new grid is called the screen grid, as shown in the diagram. Of course, like other valves, the construction is usually coaxial. The screen grid is connected to a DC voltage, as shown in the diagram on the screen. The optimum voltage is specified in a data sheet by the valve manufacturer. This voltage is set by R1 and R2, which are a potential divider. The purpose of CS is to make sure that VS is DC. It just provides a low reactance to the AC signals, sending them down to ground, rather like the purpose of CK. The characteristic of a tetrode is an improvement over that of a triode, and looks like that shown on the screen. We would operate a valve in region A on the graph. Notice the weird kink in the characteristic in region B. This kink has to be avoided, in normal use anyway, and is caused by secondary emission of electrons from the anode. An interesting thing about this kink region is that as the voltage increases, the current goes down. This is called a region of negative resistance, and it can cause instability and oscillation within the circuit. This is a major problem with tetrodes. Secondary emission happens when high-speed electrons, in this case accelerated by the constant high screen grid DC voltage, impact on the anode and knock electrons, called secondary electrons, out of it, as shown in the diagram. Basically, the kinetic energy of the primary electron is enough to overcome the work function of the anode. The kink is the reason that the simple tetrode valve is not much used and is overcome by the pentode valve. One type of tetrode did survive and is called the beam tetrode. This is still a popular valve in audio and RF power amplifiers. The beam tetrode works by using plates within the valve structure to restrict the paths which electrons can take, forming them into a beam, and it hence manages to control the secondary emission. A diagram on the screen shows a view from the top of a valve looking downwards. These beam tetrodes have very similar characteristics to the next valve we look at, the pentode, and so you can design with them in more or less exactly the same way.